This is Arvin Vora, founder of Vora Method and author of The Equation for Excellence: How to Make Your Child Excel at Math. Before you can do something quickly, you first have to learn how to do it slowly. Before you learn to run, you first learn to walk. Before you could ride a bike fast, you learned how to ride a bike slow or at all. The same thing is going to be true with math. Before you are able to make these split-second, complicated, clever algebraic decisions under pressure, before you learn how to do that, you're going to have to learn how to solve these questions at all. And for a lot of the hard questions in the SAT or physics or calculus or whatever it is you're doing, for a lot of the hard questions, even when you're taking an SAT or an AP test, it'll still take you 5 or 6 minutes. You might do a lot of the other questions quickly, but the hardest questions, they'll take some time. I want to share with you an experience of mine, and then I'm going to share with you an experience of the entire human race. Here's my experience. When I was in college, I was a math major. And at Brown, there's 2 math departments. There's the applied math, that's the easy one, pure math, the hard one. And by the end of it, there was about 7 or 10 of us in the pure math department that were graduating there. Each week, in each class, we had to do a problem set, and each problem set would take us somewhere between 20 to 40 hours. Now you might say, well, I thought you guys were good at math. Why did it take you so long? Well, because the problems were hard. You might say, well, were they very long? Were there a lot of problems? No, most of the problem sets had 5 or 10 questions. You might say, well, did they have subparts like A through Z? Nope, just 5 normal questions. Were the solutions very long? Were the proofs very, very long? Were there hundreds of steps in these problem sets? Not really. Usually the proofs were 5 or 10 steps. So what were we possibly doing for 20 to 40 hours for a single problem set? I'm going to tell you what we were doing, thinking, looking at a problem. That's what math professors in college will tell you, by the way. If you're a math major, and I hope you are, or I hope you decide to become one, that's what they tell you. Just keep looking at it, stare at it. And the other advice they'll give you is the first advice is stare at it. And the other advice is take a break from it. Go do something else. Come back and stare at it again. That's how you develop these mathematical problem solving skills. Because I spent hours and hours doing that then, now with working with you guys in calculus or SAT or whatever, I can do that basically instantly. And then you'll be able to do the same thing. Some of these problems, we want you to have a similar experience to that. We want you to have that experience of taking a problem home, staring at it, going and doing something else, coming back, staring at it again. And so whatever problem you're about to do at home, you just take at least 24 hours and try to get somewhere with it. You might not solve it. That's fine. Most people don't. But we want you to start having that experience of testing, of looking at the problem, seeing if you can figure out something, getting stuck, taking a break, coming back, taking another break. And when we say struggle with it for 24 hours, I mean you have to just sit there just staring at it for 24 hours straight. You do other stuff and let your brain work on it in the back of your mind. Let your unconscious mind do what it does so well, which is look at things from so many different angles. Now, before you say, well, maybe people who are just better at Arvin, did you ever think that maybe people are better at you than at math? Just maybe it doesn't take them that long. They don't need to sit around spending hours and hours. Not really. People who are better at me than math spend more time. This is Fermat's last theorem. The person who eventually solved it took him 35 years to solve it. And before he solved it, the human race took a few hundred years to solve it. It's just one problem. It's just one proof. It's not even that hard a proof to explain. You can have a squared plus b squared equals c squared, right? And you can find positive integers that work. 3 squared plus 4 squared, for example, equals 5 squared. But if you change this n to a 3, for example, you can't. There's no positive whole numbers such that a cubed plus b cubed equals c cubed. That's what is the proof of. It took somebody 35 years and to do it, and took everyone else hundreds of years to not be able to do it. That's what really advanced math is. So let's go ahead, take some time, have some exposure with this. You can switch subjects to something else right now, or just end class for today. And I'm going to give you the same advice that every math professor has given everybody. Stare at it for a while, then go do something else, and then stare at it some more and see if you can figure any part of it out. You don't have to solve the whole thing. You don't have to make any progress at all. It's just about learning to engage your mind in this way. And once you're able to engage these different parts of your mind, you'll be able to start doing it faster and faster and use it to dominate whatever test or whatever subject you're working on right now.